In this problem, a particle of mass m moves along a circle of radius r. We are asked to find the average force acting on the particle over a distance that is equal to quarter of the circumference of the circle. So we are asked to do this in two cases. The first case is when the particle moves along the circle with constant speed v. And the second case, when the particle moves with the constant tangential accelerations. So here the problem says velocity, but keep in mind that when a particle goes around a circle, the direction always changes from point to point. So the velocity is anyway changing. So it cannot really move with a constant velocity. It does move with a constant speed. I think the author intention is constant speed here. So now let us look at the problem. Sorry, we already looked at the problem. Now let us look at how to solve it. So this is a circle of radius r. So imagine the particle starts from here with constant speed v. So once it covers a quarter circle, the particle will be here with the same speed but pointing in a different direction. So if I call this as velocity v1 and then this is velocity v2. Now if I draw the vector triangle, okay, so the initial velocity is pointing vertically upwards and the final velocity is pointing horizontally, so that is v2. So the change in velocity will be the vector running from how can we say, so we want v2 minus v1. Okay, so v2 minus v1 is the change in velocity vector. So if I take minus v1, so minus v1 would point in the other direction. So I'll put it here. So this is minus v1 vector. So this is v2 v1 and then this is minus v1 vector. So v2 minus v1 vector will be pointing in this direction. Okay, so this is this vector. But anyway, I think we are only interested in the magnitude here. But it is a good idea to know the direction as well. So this angle is 90 degrees. And the magnitude of each velocity vector is same, that is equal to v. So the magnitude of the change in velocity vector, if I apply Pythagoras theorem here, it should be square root of v1 square plus v2 square. So which will be, so v square plus v square, so that would be 2v square. We can say this is root 2v. Okay, so we have change in velocity. And then how do we get the time taken by the particle to go from the initial position to the final position? So the time is distance by speed. So distance by speed. Okay, so what is the distance covered by the particle? It is quarter of a circle. So the circumference is 2 pi r. So we are to take 1/4 of that, that is pi r by 2 and then divided by v. So the time taken is 2 pi r, oh sorry, just pi r. So pi r v by 2. Okay, so now if you look at the average force, so the magnitude of average force will be mass multiplied by the magnitude of the average velocity. And by definition, average velocity is change in velocity by time taken. So we have change in velocity which is root 2v and the time taken is pi rv by 2. I think I messed it up here. I am really sorry here. So I think v should be downstairs. So this should be in the, so this is pi r by 2v. So put it here. So what do we get here? 2 root 2 mv square over pi r. So that is the magnitude of average force. Now this is with the first case. Now if you look at the second case, the particle is moving with constant acceleration at. Now, so in that case, so let's look at the circle again. For the second case, the problem says that the particle starts with zero velocity. So at the initial location, the velocity is 0. So v1 is 0. Now once it covers this quarter circle, so whatever velocity we have is the change in velocity, because initially you don't have any velocity. Now whenever a particle moves around the circle with tangential acceleration which is constant, we can use our kinematic equations, because the particle is anyway moving in kind of one direction even though it is moving along a circle. So we can still use kinematic equations. So if I use v square minus u square is equal to 2as. So here s, instead of displacement, we're going to use it for distance. So the final velocity v2 square minus initial velocity is 0. This is equal to 2 into tangential acceleration, and the distance covered is pi r by 2. So the final velocity magnitude is square root of at into pi r. Okay. Now if you look at the time, we can use the other kinematic equation which says s is equal to ut plus half at square. Again here s is the distance covered. So distance covered is pi r by 2. The initial velocity is 0 plus half the tangential acceleration into time square. So here t comes out to be square root of pi r by 80. Okay, now here whatever final velocity we have, that is the change in velocity's magnitude, because the initial velocity is anyway 0. So we have change in velocity and we have time taken. So the magnitude of average force is mass into the magnitude of the average acceleration, which is again change in velocity by time taken. So the change in velocity is square root of 80 into pi r, and then if I divide by the time, so we have square root of pi r by 80. So we get here mass into acceleration, and then this is again, if you look at from point to point, that is the tangential force that acts on the particle, providing the given tangential acceleration.